This video is on alkynes. Alkynes are hydrocarbons with one or more triple bonds. So alkanes are single bonds, alkenes have double bonds, alkynes have triple bonds. The general formula is CnH2n minus 2 because every time you're adding a bond, you're going to lose two more hydrogens that would have bonded. A triple bond has sigma and pi and 2 pi bonds. The simplest is ethyne, and the common name for that is acetylene. And alkynes are named in the same way as alkenes. You just change the ending from ene to yne. And because we have triple bond it only has one thing attached to either side on the carbon, there is no cis or trans. That is only with alkenes. So when it comes to naming alkynes, it's similar to the other types. So you determine your longest continuous chain, your parent chain. It has to have the triple bond in it. You're going to number the carbons in the chain, so the triple bond would be between the carbons with the lowest numbers. And you're going to identify your branching groups attached to this by name. Okay, so let's do a few examples. So name the following. All right, so we have 2 carbons. And we have a triple bond in the middle with no branches, nothing else attached. So 2 is eth, and because it's a triple bond, it's ethyne. And the common name for this is acetylene. So then let's draw the next one, propyne. So prop means 3, right? Yne means you have a triple bond. So I've got 3 carbons, and I've got 1 triple bond. It does not matter which site I put it on because either side would be the lowest. So if I put it here, that would mean this carbon has 1 hydrogen. This carbon doesn't have any others. This will be a single bond, and this one has 3, which you could draw it as 3 hydrogens, like 1 on each side, or you could just do the condensed CH3. So the next one, it says name the following. So we got to find our longest chain, and it has to include the triple bond. So there is a longer chain of carbons that doesn't include the triple bond, but we can't go that route. That would be going from here all the way to here. Okay, so we have to include the triple bond here though. So it's going to be this right here, because as I get to this kind of fork in the road, this branch, this is longer. So that tells me that I'm going to have to start numbering here. This is 1, 2, 3, 4, 5, 6. So that my triple bond's in the lowest site. My functional group here, or sorry, my branch, we should be talking about it. My substituent is with 3 carbons is prop, right? And when it's that substituent, you put the YL on it. So my name would be where my propyl is first. So it's the 3rd carbon. So 3 propyl. And then I need to say where my triple bond is. So 1 hexyne, because I have 6 carbons. If I go back up here for a second, notice I didn't say where the triple bond was in either of these, or it wasn't said in the second one, and I didn't say it in the first one, because there was no other option, right? Ethyne, you just have the 1 bond in between your 2 carbons, and propyne, no matter which spot you put it on, it's the same. All right, let's draw one more. So here I have pent, which means 5, right? Yne means I have a triple bond, right? And my triple bond is at the 2nd site. Then I have a methyl group, so I have a CH3, and that is at the 4th carbon. So I'm going to first draw my longest chain. So I pent, so I've got 5 carbons. Okay, I'm going to put in my triple bond. Doesn't matter which side I want to start counting on. I'll just start on the left. So that would be my 2nd site of bonds. So after the 2nd carbon. So this is my triple bond. And then that would make my 4th carbon be 1, 2, 3, 4, have my methyl group. Top, bottom, doesn't matter because I've got full rotation around a single bond. So I'll do this, and I'm going to add in the rest of my H's. So this would be CH3. This carbon is fully bonded. This carbon is fully bonded. This one would have 1 H. And this would have 3. So that's alkynes, a little bit more similar to alkanes in kind of the simplicity of just straightforward. We don't have to worry about cis and trans. Do things go up and down, branches, things like that.